Thank you. Thank you, everyone. Thanks for coming. It's also like Ismail, it's my first time here at the BSides Augusta. Thanks to the organization for having me here, and thanks to you for coming. So today I'm going to talk about many different things. It's probably too much to cover in just 50 minutes, but I hope you get something interesting from this talk. So I'm Toni de la Fuente. I work for Alfresco. Alfresco is a software company, open source software company, and we do a lot of stuff in the cloud. And also I have done things like Prover, which is a security tool for AWS, PHP hardening a long time ago. So yes, I have done PHP. I'm sorry. Nobody's perfect. And also I have done some security tools for Alfresco and helped with some books. So I love security, cybersecurity, and so this is why I'm here. So the idea, so what I want to tell you is a story during these last 2 years. So 2 years ago, I got this email from my boss that he got it from Amazon. So you can see that we had an instance, stopped it state because it was doing something weird. And my boss said, Toni, you are a security guy and you know some things about forensics, incident response, etc. So here you go, just play with it. And also I had another email a few months after that, the other, saying a little bit more details with also another instance doing something like a port scanning or something. So this is what you have from Amazon sometimes. If your infrastructure is doing something wrong. So what I'm going to tell you is about the bad things happen, or shit happens all the time, wherever you are working, even if it's on-prem or in the cloud. So you need to know things about digital forensics in the cloud. I'm going probably to start by the end of the story, tell you more generics about what is digital forensics in the cloud compared to digital forensics in the on-prem or in the physical world. Then we are going to see some attacks and how to automate, or others can automate attacks, and incident response, and also, of course, some hardening and security assessment to get to know your environment, your infrastructure, etc. First of all, let's talk a little bit about one of the main characteristics of the cloud is ubiquity. So in the on-prem world, you have a data center, you have a door, you open your door, and you can see all your systems, and you can disconnect manually or physically disconnect your servers from the internet or your workstations, etc. In the cloud, you cannot do that. So you have multiple places around the world. You may have today your workloads in Virginia or tomorrow in Singapore or China or whatever. The same for this is Azure or Google Cloud. So I have used some example of AWS, Azure, and Google Cloud, but probably it's the same for any other. So when it comes to deploy environments or applications in the cloud, you can do that automatically using, of course, automation tools like in the case of AWS CloudFormation. And you can deploy things like a regular application in high availability, with elasticity, with also elastic storage, many different things like custom hosts. Things that in the physical world on-prem may take months, you can do that in minutes. And also in more elaborated environments like PCI DSS, compliance environments, etc., in just minutes. But also you can destroy them in just minutes. This is why we have to pay attention to the security and hardening, not only in our systems, like the same way we do in on-prem environments, but also in the infrastructure control, because everything is an API, everything is an API call. So we have to pay a lot of attention around our systems. So let's see some generics around forensic vulnerabilities that we find in the cloud. For example, the ubiquity, as we have seen, so the legal jurisdiction, of course, is different because we may have information in many different countries. The elasticity is also an interesting point to discuss because when you have auto-scaling groups, for example, which is the feature in the cloud where, depending on many different circumstances, you may have 2 servers, 2 instances doing a task. If you have more load or more users connected, you may have 6 servers eventually. So what happens if you have an attack or an intrusion and your system has, by that time, 6 instances, but after that, 2 hours after that, you have 4. So this is also, of course, a challenge. And many other challenges. I'm not going to go through the entire table, but it's just a good thing, good list to consider. It's like other differences when it comes to do the traditional or the cloud forensic processes to do a proper forensics investigation from the identification, preservation, acquisition, etc. So, like the other table, I'm not going to go through the entire table, but just to highlight a few details here, like documentation of the scene. Of course, in the cloud, you don't have any scenes to document because it's in the cloud. So you can save the time while you are documenting this part, the physical place that you are getting in and what you find, etc. Or how challenging is to recover the erased data because you don't have physical drives to clone them. So it's different what you have to do. Or even the analysis. In this case, used to be slow in the on-prem or depending on the hardware sometimes. But in the cloud, you have multiple instance types, different hardware, very powerful hardware, or virtual hardware that you can use eventually, like 2-3 hours to pay $10, $20, $30 and have your job done. Like, I don't know, think about a timeline or a hash of an image, etc. So sometimes some tasks are better or faster in the cloud and others are more difficult. Also, we need to know where is the information. Depending, of course, on the cloud vendor, you can find information in many different places, but pretty much all the cloud vendors have the same kind of services. So you need to know the key points on the object storage, what is an object storage, and their limits, their capabilities, etc. But also, you can see here S3 or Azure storage, different options if they have information encrypted or not, different tasks that you have to perform depending on what you are going to find. Also the block storage, the EBS volumes or virtual disk, the different volume size, etc. So we can find information, this is just in a nutshell, that we can find information in many different places. And also, remember here in the corner, there is something called ephemeral hard drives, which is information that when you terminate an instance, it goes away. So you may find interesting information there as well, or databases, or queues, caching services, etc. So this is not just like in the on-prem world that you go to a server, get the hard drive or the hard drives or the array of disks and clone them. You have to think beyond that, of course. You have to think in different services. And once we have said that, we are going to go to AWS specifics. I have worked a little bit with Microsoft Azure and Google Cloud, but my daily job is in AWS. So I'm going to go straight to AWS specifics to tell you about some attacks, to tell you about some incident response automation also, and hardening. So far, so good? Okay. So in order to understand most of the attacks and how AWS work protecting services and protecting the different options that they offer, is we need to understand the keys. So first of all, when you create an AWS account, you have a root account, which is an email address and a password, and you should have this account protected by a multi-factor authentication code or hardware or software MFA. The most important point here is the IAM, which is a username and password, but also is where you control users, groups, role policies, and instance profiles. This is also very important, instance profile. And the access keys. Remember, an access key is what you use to connect the Amazon API, okay, the AWS API. And it's a pair of keys. You use these keys for everything. But in addition to the keys, you may have the STS, which is a token that gives you temporary access to something, to a resource, of course. And is used to be attached to an instance, if an instance has a profile, a role attached, or if you use SAML authentication, like third-party authentication, like OneLogin or Okta, you have also, your user have also a token, okay? Your access keys depends on a token as well. And the key pairs, that is nothing to do with the rest. This is all related to AWS properly, and the key pairs are the SSH key pairs, okay? Sometimes people is confused with different things, but SSH, the key pairs are only to access to Linux instances through SSH, and also can be used to sign URLs, but it's not the same. So when I'm talking about a key pair, I mean the access keys, I'm talking about the AWS API access keys, okay? The metadata server is a service attached, let's say, attached to every instance that can give you information about the environment where this instance lives. For example, you can ask, what is my IP address or external IP address, or the VPC where I'm part of, or even the security groups that they have, which is like the firewall that is attached to the instance, or many different things that are very helpful for service orchestration, discovery, etc. But also, from the metadata server, we can get the access key. If the instance has a role attached, we can get the access keys, and also the token. So now that we know some basics about how AWS works, let's see some attacks. Some common incidents that we can find are the access keys compromise, of course, as we have seen. There are many ways to do that, and we are going to see some of these ways. Phishing attacks, you can send emails trying to force a user to change the password or to give you keys, etc. Through compromised resources, using poison AMIs or EC2 instances. Many different ways, as you can see here. Also, the subdomain takeovers, applications running in a role. I will show you some applications, some examples, and misconfigurations. Everything is, at the end of the day, or not everything, but in most cases, are errors related to the configuration. Okay. And of course, I could miss the S3 leaks. You have heard this probably during the last months many times, like the Time Warner issue, the Verizon, Autolender, and also there is a very good list here about all the latest S3 leaks that has happened. And also, if you want to see how you can perform an audit to your S3 farm, let's say farm of buckets, you can look at this tool. It's a good proof of concept of how you can discover buckets and to discover the permissions of the buckets. I will also show you a tool, a prowler, that can help you to figure out the configuration if you have properly or not configured your buckets, but in terms of security. But this is kind of an attack tool or recon tool. It's very, very interesting if you want to take a look to it. And this is Amazon Macy. It's a new tool from Amazon, and it's the AWS answer to all these issues around the PII information leaked from S3 buckets, etc. So if you use Amazon Macy, what it does is to look at inside your buckets and also in your buckets configuration, and gives you very good information regarding, as I said, the configuration, and if you have kind of credit cards in the data or another like social security numbers, etc. using machine learning. I had to say that. Other places, or some places that you can find, and look, the list is very big. So places where you can find access keys. User data, of course, the user data is if you are familiar with Amazon, with AWS, when you launch an instance, you have seen in the advanced options a text box that you can paste a shell script, PowerShell or a shell script to run whatever you need to run, like install packages or whatever. So this is the user data, and the user data is attached to the metadata server. So from inside the instance, you can query the metadata server and get the user data. And if you don't know that, you can you paste passwords or keys or whatever you want there, you can get that if an application allows you to run a command in the server. So watch out with that. Same thing with CloudFormation or the metadata server itself. Public EBS volumes, public AMIs. Probably, I don't know if you know that, but you can make an EBS volume public. So this is very dangerous because in an EBS, which is a hard drive, virtual hard drive that you can attach to your instance, you may have information, personal information, or even keys, etc. And also in your workstation, if you use a Linux or Mac, you have credentials here or in a Windows here, and many other places, as you can see here. Even you can search in GitHub. Look at this truffle hog in GitHub. You can see a good example of how to find keys, not only in GitHub. Amazon looks also for you to try to find keys and let you know that they have found some keys. But this tool will also be the code history, so which is pretty interesting. So watch out with that. Who knows what it is? Who?
It's the drop key.
Yeah, exactly. It's a payload. Yeah. It's a payload of the. So you want this. You deserve this. It's a payload for the USB rubber band. So you can disable that in Mac just changing the Spotlight shortcut. And I've been playing with this, so don't tell my mates, but I'm going to use this next week internally in my office. So once we perform an attack, we can do, or we should do, a persistence to try to move, to do a lateral movement or whatever. So we can look, as I said, to the metadata service, like this. It's just doing a curl. I don't know if I have, yes, a curl call here to the metadata service. This is, as I said, AWS specific, but Google, OpenStack, and other vendors have exactly the same. In Microsoft Azure, they have a kind of metadata service that are files inside every instance. It's not dynamic like this one, but it's static, but it is also in every instance, okay? So this is not only a kind of an AWS issue. Well, it's not an issue, it's more related to configuration, but it's just something that exists, okay? So if you have, as I said, a role attached to an instance role, you may have also this, which is an access key, a secret key, and a token. If you take this information and you put it in your configuration, in your workstation, you can run any command with whatever permissions that these keys are allowed to do, okay? So if you get these keys and you use them in other attack automation tools, you can get a lot of information. You can get permissions or actions that you can perform in that account, or as we are going to see, to perform malicious activities. So, like lateral movement, snapshots, attach volumes to your own. You can get, if you have permissions to do that, you can share an EBS volume to attach to another EC2 instance. You don't even need the root password to do that, because it's like you connect an EBS volume to a server. This is why it's very important to have EBS volumes encrypted, for example. And you can also use Metasploit to automate some of these things. So serverless. Who is auditing serverless here? Do you know what is serverless? You are familiar more or less with serverless? Serverless is a service to run functions, different functions in Python or C# or many other languages like Node.js without having to take care of the servers. In my case, a few months ago, our developers wanted to start running some workloads with serverless because we are cool. And they say, okay, Toni, we are going to move this code to production, so what can we do? I said, okay, should I audit it? So I didn't know what to do, but I tried to make sure that it was in Python. This Python code wasn't a backdoor or something, I don't know, doing something weird, like charging too much or doing any configuration change. And also, in terms of the permissions, every function runs with a privilege, with a role. So what I did in AWS was to look at this role. In our case, here in Saba, it's a serverless framework, very, very helpful and comprehensive. And we, what I do is just to make sure that there are not many stars in the policy, because as you know, any developer wants his application to work. That's all. They don't care about permissions, they don't care about security in most cases, or at least in my experience. So, and they allow everything. So this function can do everything. So you have to just take care of that. So this is another very interesting attack. It's a little bit old, but it's also using Saba. Just having the keys, the access keys, you can disable, of course, with the proper permissions, disable CloudTrail, encrypt CloudTrails, generate new developer access keys, stop instances, terminate instances, and bar them all. Everything with just one button. So this is why I said before, so you can automate the creation, but you also can automate the destruction. So this is just a screenshot of this. And look, there are some companies have had to close just because they didn't have properly configured the Amazon infrastructure, or not properly split it in different accounts, etc. This is another very good attack. It's kind of a proof of concept using Lambda. And if you are interested in Lambda security, watch this video from the Chaos Computer conference. But the code is not available. But the video is still interesting. And there are many other attack tools or proof of concepts, very interesting, that you can see here. I'm not going to go through them because I want to tell you more about hardening and incident response. So once you find an issue, or you have the issue, how can you identify the issue? First, with AWS or the vendor notifications, they have very good security teams, and they are looking after everything more than what you maybe think, and very proactive all the time. Also looking at the IAM activity and the new cloud IDS, which is the billing activity. If someone take your keys and start creating instances to mine Bitcoins or to do whatever they want to do, you are going to see that in your billing, of course. API logs, as I said, everything goes through the API, so you have to look at the logs, and of course, dedicated tools. We are going to see some of them, and the traditional tools like Snort, Suricata, or Wasu, which is a fork on asteroids with OFOSEC, OSquarey, RK Hunter, ODD, and everything that you already know, probably. So, yeah, I know this is too big, but it's what I try to put in just one slide everything or almost everything that you have to do when you have an attack in the cloud. So you have to do a lot of things, as you see. Some of them are like in the on-prem, what you have to do on-prem, but let's say that in the cloud you have to do a few more things. For example, you may have an instance compromise or a key compromise. And of course, you can trigger network capture, you can create an internal case, you can create a support case, you have to do many different things. And you can automate most of them. So far, we have automated the main ones, which is not bad, but it's still a lot of work to do. And also, depending on the case, you may need to leave the instance live or to stop the instance. Or maybe you already have the instance stop it, and they call you to look at it once it is stopped. So we have automated the memory capture and some other data like metadata, etc. And also you can also use forensics distribution in the cloud. More or less the same way. You have to attach volumes to do to create timelines, etc. So, of course, we need to do a lot of more things, but it's not bad. So I'm going to show you a demo how we have automated all of these things. In the cloud, you have also to acquire more information, like not only the cloud trail, which is the API trail, the VPC flow logs. If you are not familiar with VPC, it's a way to create networks, private networks in the cloud. S3 logs, RDS logs, everything that you can get. But also the instance profile information, endpoints, if you have endpoints configured, the syslog, screen, and metadata from the hypervisor standpoint. We don't have in the cloud, of course, information from the hypervisor, but Amazon, in AWS, you can get some information from the hypervisor, like even a screenshot of the console in a particular moment for either Linux or Windows, which may be interesting when you are doing an investigation, and many other information, that data like limits in this account. You need to look for resources created from a given date, from the data, for example, that you figure out that your keys were stolen, for example, and everything from inside every instance. So you have to acquire a lot of information, and you can automate pretty much everything of this. So the tool that I'm going to show you is based in. It was presented in the Black Hat, and it's based more or less in the idea that I wrote in an article back in 2016, with a proof of concept of how to automate what I have shown you. And I had these kind of examples how to get some information from a shell script using the AWS CLI, and the guys of Threat Response presented this tool at Black Hat 2016, and also a new version this year. you have this, all the tools here and documentation, etc. And what I'm going to show you is how to collect how to respond to a key compromise and how to respond to an instance compromise. What we can do is, using plugins, you can gather the instance. You can see here host, but it's actually an instance. Metadata, screen, console, etc. Also to tag the host to make sure that your information, the instance is tagged and is under investigation. To add an ACL, if it's inside a VPC, to add an ACL to make sure that only the examiner, the investigator, can access to it. The same way that isolate it is like to move. You need to keep the instance running, but you have to make sure that nobody is going to, or nothing is going to get out of the instance or inside the instance, but your investigator instance, for example, through SSH if you want. And eventually stop the instance if you need to. So let's see first key compromise. In this case, it's not only to, we see here, if you are familiar with the AWS console, you can see here the one account. Is this running? Oh no. The video is not running. Is it? No. 1 second. I have it here in. By the way, this is where you can find everything I'm talking here. The video of the instance compromise. I'm going to go straight to the instance compromise. So here you can see an instance with its own security group, etc. So what I do, let me stop it a little bit. What I do here is running AWS IR, which is the command to perform an action in this case, in the instance compromise case, and I give it a bucket name to leave there the memory dump, and you have to give it the Ubuntu, the user, the SSH key, and plugins. The plugins at the end of the day is the order that the different or the workflow of the actions that you want to perform, like gather host, etc. And it depends of course the size of the instance. What you do is just to take to perform all these different actions in minutes. So with the target, which is the instance that is compromised, it tries to find this instance in all the different regions, AWS regions, and perform the different actions. For example, using, I don't know, do you know Paramico? Paramico is an SSH tool library for Python. So threat response, the suite of tools, has one tool just for the memory dump, remote memory gathering, which is called Margarita Shotgun. Margarita Shotgun is based on Paramico. So here you can see, in this case it was a 1 gig RAM instance, but this is why it was very, very fast. So you have there the URL of the instance, the memory dump, and the different options, the different acquisitions. So the console, metadata, also the screenshot, etc. So here you can see automatically you have changed the security group only to the isolation security group, which is your investigator IP address, and it's stopping of course the instance, and you have also a snapshot created automatically. So what you can do with this snapshot is attach it to Cain or the SANSIFT, for example, or any other forensics distribution in the cloud and to perform other tasks, like to create a timeline and export this timeline to Plazo, for example, etc. And also creates in the S3 bucket you can find the memory dump. And I don't know if you are familiar with Line, but in this case, what it does also automatically is these guys have done a repository of kernel modules based on pretty much all the kernels available in the market, and they have it available in an S3 bucket somewhere. And this tool looks at your kernel in your Linux and takes automatically this kernel module to perform the memory dump. As you know, to be able to do a memory dump in Linux, you need to install a module. So this is why everything works so fast, and you don't need to do anything manually. And now, with this dump, using recall or volatility, you can perform other tasks, okay, to find what the issue was, etc. Okay. Let me go back here. Okay, this is more or less how to automate the data acquisition, to change some things in the cloud in an automated fashion. How you can prevent persistence? So having good configuration, first of all, but look in detail to your user data. There are ways to make sure that you don't have anything like keys, etc., in your user data. So there are security best practices when you design the templates with CloudFormation. Also, you can prevent that an application like Apache or Java application running with the Tomcat user or with the Apache user or something like that connect to the metadata server, just adding this IP table rule. If you have everything with STS token, you make everything more secure temporarily, unless you give permissions to extend the tokens from the same policy. CloudTrail should be enabled always. So I think since a month or 2 months ago, every new account that you create in Amazon has a CloudTrail enabled. So make sure that it is enabled, because it's the only way that you have to see who has done what through the API. And separation of duties using multiple accounts, of course. To implement a good policy about security in the cloud, you need to go from the ground up, from the instance security to the network security to the provider, as we have seen. Some tools that we used and we decide also to use. I have another list of tools, but for example, every instance, every AMI that we build should have the CIS benchmark for the operating system to make sure that it's properly hardened, and the hardening is applied. No configuration so if you don't need to configure it, you don't need to access to it, despite some users have SSH access, but if you use a configuration management system, you don't need to SSH to any instance. And also local tools like Osquery, Wazoo, RK Hunter, etc. And of course, SE Linux always enabled. Remember that you can collect everything from your provider, but every provider has also an API call limits. AWS has API call limits depending on the different actions. And of course, red teaming, API calls, I already have talked about this, who, when, what call, what resources, and from where happens. This is CloudTrail, and also every cloud provider has a tool, but also Microsoft has the operational insights which is more than just API calls, but they have tools for everything. And also there are proprietary and open source tools. Yes?
What are your thoughts on Amazon Inspector for auditing, scanning, hardening? Do you have any experience with it? Is it good, bad?
Yeah, it's not bad, but we have played with just one project with Inspector, and also we are using Wazoo, the latest version of Wazoo. As I said, Wazoo is a fork of OSEC, comes with an integration with OpenSCAP.
Oh, okay.
And OpenSCAP is also a hardening and compliance tool that look at your configuration, etc., and can give you clues about if you have properly hardened, secured your operating system based of CIS benchmarks or even NIST or different standards. So we use OpenSCAP, but we have also used Inspector. It's fine. Inspector at the end of the day look at also benchmarks, etc. Also, as I said, to automate hardening, auditing, etc., you can use many different tools. I'm going to highlight a few of them only. All the links are in the GitHub page, and also are in the presentation. Everything is in GitHub already. I like to highlight, first of all, SecurityMonkey. I cannot live without SecurityMonkey. SecurityMonkey is a tool by Netflix, and it works for AWS and recently for Google Cloud as well. And what it does is to look for changes in the API and in your configuration and alerts for bad configurations or some changes. It has some patterns to know if there are some bad configurations and give you some advices and alerts about those configurations. Amazon has done good things about some changes like config rules and other tools like Amazon Macy, as we have seen before. But SecurityMonkey is for me, is the best tool to look after the configuration itself, not the API itself. And you can use it for multiple accounts, not just one. Also, this is another good tool called Cloud Custodian to control policies about your infrastructure. The Wazoo plugin for AWS, and also Track2 or the AWS CIS benchmark, which is a Python code, does more or less the same as Prowler. I'm going to show you a demo of Prowler, which is, as I said, like it's based also in the benchmark, and has less checks than Scout2, but it's a little bit easier to run because it's a shell script. You don't have to install anything, just having the AWS CLI works fine. And just to highlight another thing, Git secrets is a hook for Git to prevent your developers to send when they do commit to GitHub to send keys. Okay, so it's a good recommendation for developers. And yeah, finally, well, I'm going to show you a little bit about Prowler. As I said, is a shell script tool that I have right here. It's open source, so I'm not going to sell you anything. This one. So this demo is about automating the hardening itself. So you can, it's about hardening and Prowler. I have both of them in the same video. So you can take CloudFormation Template, which is this one, from the URL that I show you of AWS CIS benchmark. It's a good example of how to automate the hardening of your AWS account, to change account policies, like password policies, and also alerts in case someone changed a VPC configuration or security group, or open a security group SSH for the entire internet, etc. So you can automate all of this stuff. You don't have to do your hardening manually, okay? And let me move forward because we are almost, and this is Prowler. So you run Prowler and you get some checks like to make sure that your password has the different values, the length of the password, and you have to change the password every a number of days, etc. And also I don't know, but probably in the 2 weeks ago, 3 weeks ago, I added an extras checks, which is beyond the CIS benchmark, to check the security of your S3 packets, to make sure that you have properly configured your S3 packets, that you don't have your S3 packets with ACL public or with policies. Remember, the S3 packets have ACLs and policies, both of them. And you may see in the ACL side that everything is fine, but a policy may have your packet open. So you have to look at both of them, okay? And the same for EBS volumes. If a developer, which has been my case sometimes, wants to share what they have done with someone else, they just make it an EBS volume public. And they don't know, or they didn't figure out that they had keys or code or many different things that is public. So I added this check to Prowler just to make sure that I can run Prowler against one account or all our accounts. I don't know in your case, but I manage more than 20 accounts, AWS accounts, with multiple resources on each account and in multiple locations. So you have to do a lot of work around 8 a.m. To prevent things happening in different regions, but also to prevent bad configurations, policies, etc. So this is the way we do internally all this kind of assessment, at least. Okay. So you can see here if you have properly configured the VPCs also with the flow logs enable, etc. Just to make sure that you have the basics regarding security in your account, okay? This is what I have shown. Takeaways. So everything that I have shown, templates, and also the presentations with the director cuts. So the presentation I had was too big, but it's available also here. And I think that's all. Yeah, remember to automate everything. You can automate everything because at the end of the day, everything is an API call. Encrypt also encryption everywhere, any layer, even if it's inside a VPC, encrypt everything, on-prem, on transit, everything. Enable account separation, never use the same account for everything. Use different accounts, not only for production test, development, etc., but also for different groups or different work groups. It's much better to use multiple accounts. And AWS, in the case of AWS, they have a new service called AWS Organizations and helps you to manage multiple accounts. Least privilege. If you ask me what is the best thing, the first thing that you have to learn going to the cloud is about the identity and access management, period, okay? And go to immutability or ephemeral resources, and of course, buy Bitcoins just in case. That's all. I don't know if you have questions. Yeah, you should have questions if you want what I have here. Yes?
So your Prowler script, do you normally run that like every, give a cadence, running it every 2 weeks? Or do you have it set up where it runs in the background and it alerts you if a developer puts in an S3 bucket and opens the world with sensitive data? Right?
You can run it in the CS mode and export it and then do this. You can do that automatically. You can do it every day if you want, or every week. This also mentioned this is it. So, what do you prefer? I don't know. Yeah, not Georgia. I left mine in the screen. Yes.
Have you done anything with like the HashiCorp, like Terraform or anything like that, as far as for managing the AWS configuration?
Yeah, we have played with Terraform, but the point of Terraform in our case, is that it's always behind CloudFormation. We do pretty much everything with CloudFormation, and we are very close to AWS in terms of deployments, etc. Using CloudFormation is easier for us. So we have played with Terraform, and it's good if you use multiple clouds. But even if you use multiple cloud vendors, it's not perfect. I mean, your Terraform templates are different depending on the vendors. So most people think that it's just an abstraction layer, but it is not actually a real abstraction layer. So we prefer to go straight with CloudFormation in case of AWS. But it's a good option. Next, I think next was. Okay, I'm sorry. Oh, it was. Sorry.
Have you found any viability in the use of the CASB solution for monitoring cloud applications?
Isolation cloud applications?
No, like using a CASB solution on cloud access security broker in monitoring like infrastructure as a service.
No, we don't have many SaaS applications. But I'm not sure if I understood correctly what you are asking. But
So it's like a cloud setting.
my experience with seeing applications in the cloud is not very positive, but because they, as you have seen, the API is so important in the cloud, and seems used not to look at the API. So there is an interesting tool that we made a try, which is called Allenwall UCN. I don't remember the name, but this is a kind of an application that tries to do like Allenwall C plus Security Monkey, but it doesn't do what we expected. So, something else? So I'm out of here. If you want to do it, thank you.